So what I'm going to explain today is something that we are working on as part of a very advanced technology integration project funded by the European Commission under a call for collaboration between Korea and Europe. So it's the only one funded last year. We have partners, for example, LGU, which is a big IT company, and their, let's say, artificial intelligence group is participating in this project. And also some leading companies and partners from Europe, of course. So the topic of this presentation is about how to develop a technological platform that is going to help build smarter and safer construction sites. So what we use are some decentralized technologies which are called fog computing. It's an advancement of the cloud computing technology. And what we actually do in this project is we put artificial intelligence applications on top of that platform that can be used in real time. So I'm going to say a few things about this. So, of course, the focus is the construction process, and we are, as part of the project, interdisciplinary collaborating. We have also people who are actually, for example, architects and so on, that are involved in such processes and can advise us on how to what kind of things would be interesting for us to be included in the initial applications that we are going to build on top of this platform. And the enabling technologies that we are working with are, first of all, the Internet of Things, which means technological platforms that enable sensors and video to be integrated and used within the platform, cloud computing, and artificial intelligence. Finally, we also use blockchain technology because our system is completely decentralized. So I'm going to talk about also the digital twin, which was touched upon by the previous presentations. So as we all know, there are plenty of parts of the construction process that we can, focus on. In the course of our project, we did initially an analysis of specific areas that could be tackled first, because it's a very, let's say, challenge to build a platform like that and also to implement applications on top of the platform. So we must come together in a way that integrates the technology, but on the other side also it is possible to show benefits of the computing platform to, for example, save time, save money, help in the energy efficiency and sustainability part of the processes, and so on. So we have a study that we have published recently dealing with analysis on this. For example, we have areas that we focus on, like safety at work, construction monitoring, early disaster warning, like any area where there could be an accident happening, management of resources and assets, and a construction site management. So, for example, so looking at this figure from the viewpoint of technology, let's say we have a camera that is observing certain things on the construction site, and we have some AI, so artificial intelligence, that is capable of capturing information from what is being seen or what is being sensed in the environment. So, for example, one could, segment this picture, put it into pieces, many pieces, and then send it to the artificial intelligence method, and the method would, calculate and just inform, like prepare a notification saying, look, there are so much materials on the ground on this place, for example. we are doing quite a lot of design studies. So, for example, we are actually studying actual construction sites of smaller size for the time being, because we need to progress from the small to the, as Professor Scherer said, from the less complex to the more complex things. And as you can see, for example, we could put 4 cameras on the site, and we could have you know, these colorful dots. They would represent different people, like a worker, person without a helmet. We could also have zones in the site saying this zone, if somebody is in this zone, then it means that there is something dangerous, or there should be the, let's say, the supervisor should be notified, and one responsible person on the construction site should be aware of that happening. For example, you could be asking then the system how many workers are currently at the site, or you could be asking what happened yesterday at 12 o'clock, so how many people were there, or was there anyone not wearing a helmet? And of course, because it's artificial intelligence, you could capture probably from this environment things that people would not like to know or to be recorded, like is the person happy or not happy, distressed, you know, any sort of things could also be captured, right? So speaking about the fog computing platform, so you can see here it's like very complex. So I'm not going to go into the technology, but it's the, let's say, the currently most challenging part is the integration of quite a lot of technologies, which means IoT, the Internet of Things. Then it's the cloud technology, where the application should run, because we cannot send the data far away, like from here to the United States for analysis. We have privacy and security concerns and other things. And then, of course, how to deploy artificial intelligence algorithms in a very distributed fashion, so that you can, you know, like distribute the whole process of AI. And then, of course, so this is like a cyber-physical system. And it starts from the construction site, but then there is a lot of processing, and information should be coming back within milliseconds, not within hours, as we just heard in the past presentations. So, for example, here we have deep learning. Deep learning is a very interesting topic in AI, currently a very hot topic, because they discovered recently that you know, if you put information to a neural network, and the neural network is a little bit bigger, like deeper, then it can record and know much more than it was previously thought. So after 20 years of research, there is a, you know, like a big change in this area, and many more things can be discovered from, let's say, videos or photos. So, for example, out of that figure, there could be like a TensorFlow, they call it, or different technologies that we use in the project that can identify in the form of a text what's going on. For example, the person is wearing a helmet. So that would be really nice, yeah. So if you look at that, while passing through that distributed neural network, the information comes like that, and it's being degraded, and in the end it comes out with the solution, like the person wears a helmet or not, is he happy or not. So there are many people who are doing plenty of things and teach the networks to do things. So it's really amazing what things can be doing. So if you look at the big data processing pipeline, you have a construction site where you have plenty of things. So it's very complex, as we heard. And then there is this process of getting the information, like what is the vehicle plate, or the person wearing a helmet, license plate of the vehicle that came to the site, for example. And you could be knowing who came, when was this car registered to get in or not, and things like that, like what type of material has been there. And you could be questioning the system later on, what are the quantities at this point of time, or who is where, and things like that. So these are like examples of how, for example, current systems are being developed, and we have some systems like that, so that we can put a video, and then we can get in these bounding boxes information recorded by for what is happening on what the camera is being observing. So finally, the digital twin, which is, I think I agree completely with the definition from Professor Scherer about this real-time aspect. So actually what we are focusing here on is that you get information from many different sources. So once you identify the pieces of information, you could be integrating it in a knowledge base, and there are technologies like that. And it's a little bit scary. So actually a part of our project is devoted to what we can question the system, because it would be a Google-like, you know, Google-like, and you would be asking a question in a very near future, like saying where I was yesterday at 5 o'clock in the afternoon, or what the person ate for dinner, you know. Or you could be asking other things, of course, that are of less construction-related matters that could be important for the process. And you could be, of course, getting real-time notifications. So I call that augmented virtuality, actually, this integration between the beam and the actual reality, which is captured by this sensing environment of sensors and cameras and things like that. So I call it augmented virtuality, because on the top of the building information model, we get quite a lot of information coming from the real world, so that we can actually question the model about the things that are of importance, and they're in real time added to the model, right? Or, you know, we can compare the model and the reality, as you can see here. So that's the summary of my talk. I would say that setting up that, it's far from reality. There are some people that say in artificial intelligence that there would be an ice age in near future, again, for artificial intelligence. But this is the current state of technology that I just described. And the implementation of these big data pipelines from the site to the information system that is serving the information, that is sending notifications on the mobile phone, is what we are actually focusing on in this project. So we are dealing with quality of service, privacy, security, dependability, trust questions, which are of importance when one tries to build a platform, a fog computing platform that will help automate the process. So that, I think, we are organizing a few events, but I just want to skip this. If you like, you can have a look at the presentation. So I would say that these 4 technologies, I call them quadrumvirate, because it's 4 of the winning, right, are going to become basis for the, let's say, smarter and safer operation of construction sites in very near future. I've seen applications, for example, in Korea, in the construction sector, which are really very, very advanced, I would say. And they are dealing with similar topics as we deal in the project. So, thank you very much.